What is going on? Today I want to talk to you guys about manufacturing automation protocols, aka communication protocols. What does that mean? What does it relate to the past versus now and today with our current technologies that we have? And I'm going to also relate this a little bit to a discrete type of signal. And if you don't know what that means, we'll explain that a little bit as well. I'm the CEO of Elite Automation and have been doing controls engineering and system building for over 10 years now, and have gained a ton of experience, and also was a controls engineer at one point in time. So I've had a lot of exposure to all things automation and including the programming side of things. So what are communication protocols? This was a really confusing thing for me when I first got started in this industry. It was a communication protocol. What is this? And then I heard different names. I heard of RS-232, I heard of 485, I heard of Ethernet IP, but I just couldn't grasp and understand what it meant. And one of the things that you have to understand is just understand that it's a word, right? Don't get so caught up in exactly what the thing is. Let's say, for instance, Ethernet IP. To actually understand the fundamentals of how it works is much more than is required to do anything in industrial automation. You really only need to know how to set the thing up. And so let's dive back into how does this relate to discrete signals? How is it different from a discrete signal? And how have the technologies changed? Well, a discrete signal would be something just an on and off type of signal, right? It's a simple electrical signal that is either you're receiving a voltage or receiving a current, and that is what is determining an on and off state of a device. There's also other things that are like analog signals, which are a little bit closer to what a communication protocol is, where we're receiving a range of voltages or a range of amperages to get a signal. Now, with communication protocols, what this does is it gives us the ability to take a bunch of these discrete signals or a bunch of data packets and put them all together and send them as one chunk of data, and be able to do that very quickly. Now, with different communication protocols, what happens there is these communication protocols are structured differently, right? And I'm not going to give you an exact real-world example of a communication protocol, but I'll give you a simple, dumbed-down version of what a communication protocol is and how it may look different. So let's say, for instance, we're going to send an Ethernet packet, and we'll compare that to another communication protocol like a Profinet packet, right? This is pure example's sake, and try to get you to understand how these protocols are different from one another on the back end. Let's say, for instance, we're sending this data packet, right? And in the front of the Ethernet data packet, you have a 1. Right? And then you have a bunch of other data. Well, let's say, for instance, in the Profinet protocol, you have a bunch of data and then you send a 1. Or let's say one of the differences between these protocols is the way that they send their packet. So in the Ethernet protocol, it sends that 1 as an identifier of here's the packet's coming, right? So notice it's saying here's the packet's coming, and then the other one is at the end, so maybe you're saying the packet has came. So this is just a way on the back end at the very deep level how these communication protocols are different from one another. Now, on the surface level, what does that mean to you? Well, what will happen with a lot of these communication protocols is the setup will be very different, right? Now, some things are a user interface, which makes the setup different, and other things are a very hard, structured communication protocol. Let's say, for instance, something like Profibus. Let's say, for example, for something like Modbus. Modbus has a very structured communication protocol where the data comes in a certain way, right? And what do I mean by the data comes in a certain way? What I mean is, let's say, for example, your inputs come in, right? Then your outputs come in, and then your integer data comes in, which means like your numbers. Like, let's say, for instance, you want to transfer a number 10, that would be in that integer data. And so it's structured, and I'm just giving you a brief example's sake. This is not the exact. You can look up different tables that will identify what these different protocols, how they're structured, right? So not every protocol is not structured in a very set manner as Modbus is. And that's one thing that's really nice about Modbus. You know, no matter what, whenever you have a communication between any two devices over Modbus, that my inputs are coming in here, my outputs are coming in here, my integer data is going to come in here. And so with that being said, things are set up in a very easy manner. One of the challenges with that is your data is set to a certain size. You can't necessarily expand that data. and you also don't have the flexibility to adjust that data. Now let's go with a communication protocol like Ethernet IP. So with a lot of devices, let's say for instance we have a PLC and a robot talking to one another, you're able to adjust those different sizes of data that you want to talk. Now, in the past, this was really much more important because the amount of data that you sent really had a huge impact on your data's cycle time, right? And so if you started sending too much data, you'd bog down the whole data chain and could completely crash your network. Nowadays, it's not as big of a deal. However, I think it's something to be very mindful of. But I think the more important thing today is organization, right? So that way, whenever you develop a system, you develop them in a very repetitive way, and also you build them in a very efficient way. So whenever you define like how many inputs and how many outputs you need in the system, and how many integer data points you'll need for a robot, how many group inputs or outputs you'll need, now you can set your data size for your inputs and your outputs to match. And they have to match, right? Your PLC data inputs and input and output data have to match the PLC, have to match the robot. They're set up so that those two are connected and talking to one another. So you'll set it up on the PLC, you'll set it up on the robot, now they communicate. And then you have to do that with every single device. So if your PLC is talking to, not your HMI is set up on a little bit different platform, but if you have other additional robots in the system or any other auxiliary equipment, you would have to set up a communication connection between those two devices and set up how much information that you're looking to send back and forth. So again, like one thing that's really nice about this, let's say for instance you have 20 robots in the system, and the most data that's going to be used is 4 words in, 4 words out, and you don't have to know this, but you could have all the robots set to 4 words in, 4 words out, and now all your robots are set up uniformly. You're set up so that you have enough data for your robot that needs the most data, and your data is all uniform across all the robots. Now, you could minimize the data sizes to be utilizing only close to the amount of data that's needed, but I like uniformity more than I'm worried about trying to save a little bit extra data in communication between the robots. And that helps eliminate like issues like, oh, I thought robot 6 was supposed to have 8 words of data and not 2, and you know what I mean? And then there ends up being all these weird issues with like, why are we worrying about how many words of data that are there, especially when you're in a position where data constraints are not as big of a deal as they used to be. So I'm gonna go ahead and mention just a few different data types that I feel like are very prominent in today's time. And don't get me wrong, I'm probably leaving out some data types, but these are the ones that I get the most exposure to. And it'd be Ethernet IP, Profinet, IO link. Those are just a few of the data types that that are very prominent in our industry and very popular in our industry as well. And some of these data types, we're also going into the next level of those. And when I say the next level, I mean we're adding safety on top of these communication protocols. Whereas these communication protocols a lot of times are already a safe communication method. Now we're adding extra layers to the protocol to make them a safer protocol. So now we have what's called CIP safety, right? Which is essentially safety over Ethernet, which means we can pass safety signals from devices like the PLC to the robot to do things such as an e-stop condition. And then for Profinet, you have ProfiSafe. And this is the same type of concept. You're essentially able to send safety signals over the network. And I love this. This is something that I think should be inside of every single machine, especially if it's a larger capital piece of equipment. You can just do all of your safety setup over a network. There's no hardwired connections. You set up the communication between the devices, and then after you have the communication set up, now there's different IOs and stuff that you can modify and change on the fly to adapt the safety of the robot. Right? And so let's say, for instance, you recognize an unsafe situation. Instead of having to have an electrician come out, rewire more wires, add a new relay, do all these things, literally you just go into the PLC, add the conditions that you want to be able to have a safe condition for, and you're done. Right? Don't get me wrong, you might need to add some input hardware, and that might be there, but also another thing that has become easier, with the safety device, you generally have, it's a hardwired safety device, you have 2 OSSD wires that come off of that, and there are 2, safety chains, and you can wire that directly into a safety input card, right? Which you might already have other safety devices in that area and a safety input card that's located near to the device. And so now you're able to expand a safety system much more easily. Like say for instance, we use Allen Bradley's GuardLogix PLC, and then we use remote IO throughout the system. So let's say for instance, if we have an HMI station, the HMI station has an e-stop button on it. It also has a remote IO module in there, and has safe input cards, so that way the e-stop that's on that is tied right to that remote IO module, and the wiring for that e-stop is very minimal. There's like literally less than 3 feet of wiring for that e-stop. So if ever there's an issue where that e-stop is not working, we're able to troubleshoot that very, very easily. And also with the way these networks are being set up now you can also identify that e-stop stopped working before anybody pressed it, right? You can send pulsated signals through the e-stop that is essentially testing continuously, always, throughout its entire lifetime, if that e-stop is good. So there's not any conditions of Billy Joe hit that e-stop button and it didn't do anything, right? At least from a wiring standpoint, it can't be defeated, and it can't be, the wiring can't be manipulated. Everything is in a much more safe condition. And this is able to be accomplished because of communication protocols, right? If that communication protocol wasn't there for the remote IO module that connects the remote IO module to the PLC, that is the conduit, that is the connector between the two that allows us to be able to perform things like this safety over Ethernet. And the ProfiSafe is the same type of thing. It's the exact same methodology. The setup will be a little bit different, and the way devices communicate on the back end will be different, but the technology is essentially the same. Now, to go back against that, there are some devices that will have ProfiSafe built into them. Let me use a laser scanner, for example. Some devices might have ProfiSafe built into the laser scanner, right? Whereas maybe this same laser scanner doesn't have a safety over Ethernet version of it, and vice versa. You might have a safety over Ethernet version of it, but you don't have a ProfiSafe version of it. So it's because it's still a new enough thing in the market that not every brand is caught up, or a brand has made the decision, we're gonna focus on ProfiSafe, whereas another brand made the decision of we're gonna focus on SIP safety, and then later on we'll worry about the other. And so this is just part of the business strategy for their companies, and what route they decided to go. I think, however, there'll be a SIP safety and a ProfiSafe version of all pieces of equipment into the future. Now, I don't want to talk a whole heck of a lot on like the history of communication protocols, and to be honest, it's because I haven't had a whole heck of a lot of exposure to it. I came into the industry like right around the time when RS-485 technologies were kind of going out, and RS-232, and don't get me wrong, they were still a viable option kind of in that time. However, with me being younger coming into the industry, I kind of just seen this is an old, antiquated way of going about communicating between devices, and there's a newer and better way to start communicating. And also I did a lot of work with new capital systems, right? So let's put the newest, best, greatest version of things into the system. Now, don't get me wrong, I've had a little bit of exposure to them, but these communication protocols were doing similar things to the way that Ethernet is. Some people would even argue to say they're a more robust technology. I can't really speak on that because, again, I didn't have a ton of exposure to it. So I've had some issues with this, so I personally just don't like it. But for example, one time we did a capital install, and the customer wanted some, I think it was 485, some Modicon modules or something like that. And so, we had to do the daisy chaining of that network. That's another thing is too, some of these other protocols have to be daisy chained from one another. And then if you lose a node in between, then you lose other nodes, and then you have to trace down where you lost it at. That's just a whole nother topic. Whereas things like Ethernet, if you lose one of your remote IO modules, you can see it right in your network tree that this module right here is gone or not communicating. Go find out where it's at, see what the problem is. Do you either don't have power on it, you can test your Ethernet cable by putting a cable reader on it or cable meter, and testing the cable itself to see if it's good. And if those things check out, then your module's bad, right? Or you've seen an issue with either you don't have power or your Ethernet cable's bad, right? Very, very, very simple as far as being able to troubleshoot and find what the root cause is. And to talk a little bit more on the history as well. So I mentioned Profinet before and ProfiSafe. There is and was Profibus. So it is similar to the RS-485 type of network where it's an older serial communication, and basically serial or Profibus developed and turned into Profinet. So it's like, again, like it's Ethernet version of the Profibus communication protocol. And there was a bunch of other communication protocols that are still around, and some people do use them. However, like a lot of people just hated them. They didn't like the protocols. Like we had like DeviceNet, ControlNet. Those are a couple of the older ones that I feel like have went away quite a bit. IO-Link has came into the market and is one of the leaders in communication protocols that I would say are outside of these Profinet and outside of the Ethernet IP, because it remains on like its own protocol, right? And the one thing that's really, really cool about the IO-Link communication protocol is you have 24 volts, 0 volts in a single wire. And it's a regular wire, it's not a special wire. It can be hand wired, hard wired if you want to. So that's one thing that's really cool about the IO-Link network. And also they just built a really good infrastructure on it and a way of setting up new devices and adding devices to it and being able to daisy chain devices. It's a really good remote IO type of platform. So like if we don't use like Allen Bradley's remote IO ANT modules for our remote IO, then we use IO-Link's input and output hubs and pneumatic bank, like sub-D modules. So overall, it's just a really good product that you can plug in smart devices into, and you can get a lot of feedback for like, cycle times of a sensor, the temperature of a sensor, the lifetime of the sensor. You can just collect so much data around things like sensors, and even sensors have like even a regular IO sensor has weird things built in. I'll say weird, but valuable things built in like vibration detection. So that way, if that sensor's mounted next to a motor, it can detect the vibration of the motor at time of install, and then monitor that over time, and then say, oh, this motor, this conveyor is starting to vibrate 10 times more than whenever it was installed. We might want to have something serviced. Maybe it needs to be greased, maybe some gear or sprocket needs to be replaced, especially if it has some acute change. Like today it was running like this, and the next day it 10x'd its vibration. You're able to detect that through those sensors and whatnot. So these communication protocols are really just opening up the doors and the capabilities to have devices be able to talk to one another and to be able to communicate with one another. If you have any more questions revolved around communication protocols and some of the things that are out there on the market, feel free to let us know. Again, I'm not a huge protocol expert. However, I've had my hands in quite a few different protocols. I've set up quite a few devices on communication protocols, and they're just they're just the backbone on how devices are talking to one another, and how technologies are able to advance and share data and overall just have smarter systems as we grow as a manufacturing industry. Thank you guys, and I'll catch you on the next one.